in our previous two parts, and in this part we will be discussing mostly about chemical bond. There are some critical valuable information in the different writers' book regarding chemical bond, and most specifically I would say regarding hydrogen bond and hybridization. These two topics are very much versatile. Some different kind of questions tend to appear in different admission tests. So anyone willing to participate in the admission test should have a good grasp of knowledge regarding the hybridization as well as other bondings. And today we are going to minimize those gaps, which you have by only reading the main book. Anyway, let's start. Regarding chemical bonds, there are some exclusive properties written in the Kopisar book, but fortunately these are some basic ideas regarding those bonds. We do have this idea, and we certainly have discussed it or read it during our main book preparation or the regular master class. In this section, as we can see, ionic compounds must be polar. So it is nothing new. It is known to us. It's polar, and the structure should be crystalline. Sodium chloride takes the form of a face-centered cube. Basically, it is side-centered cube, not face-centered. Yet it is written face-centered, so you have to write it as well because of the version of that book. Anyway, melting and boiling point. It is very important. I'm marking this with yellow color or red color. In fact, boiling point of sodium chloride is 1407 or 1470 degree, not 147 degree. This is 1470 degree. Let me write it again. This is a bit wrong here. It should be 147 degree Celsius. Okay, whereas the boiling point of a covalent chloride, which is carbon tetrachloride, is only 77 degree. This is the difference between a covalent compound and an ionic compound. Ionic compound shows higher boiling point, while the covalent compound shows lower boiling point. Regarding solubility, polar compound will dissolve into polar solvents. This is what we mean by like dissolves like. And electrical conductivity, here twist also there. Not every state of any compound will conduct electricity. I have to write it down that only in molten or dissolved state. Whenever it is molten or dissolved, then there is chance of free flow of ions. That's how they will conduct electricity. And regarding covalent bond, we know covalent means sharing of electron, and that's what it is written in the definition. And who proposed this covalent bond? Scientist G.N. Lewis. Theories regarding formation of covalent bond, there are two important theories. One is valence bond theory, where the valence electrons participates in forming the covalent bond by sharing their outermost electrons. On the other hand, there are molecular orbital theory, where orbital gets to overlap with each other to form a shared bond. Anyway, these are the theories regarding covalent bond formation. We all know about the comparison between ionic and covalent bond. Let's recapitulate it. Like, covalent bond is between non-metal and non-metal, while metal and non-metal participates in ionic bond. Prerequisite of bond formation. Here, these are very important information. Metals should have low ionization energy, while the non-metals should have high electron affinity. So, what are the conditions? What are the conditions for metals and non-metals? What are the conditions for metal and non-metal? You have to memorize. Low ionization potential for metals and high electron affinity for non-metals. And lastly, high lattice power. The spelling is a bit wrong. Let me correct it. The lattice should be written as lattice. High lattice power of the resulting compounds. Okay. So when when the metals and non-metals come closer to each other, electrostatic force of attraction will compel them to stick together, and that's how a lattice is formed, and which will require a high level of energy to break it down. Anyway, regarding covalent bond, here since it is between non-metal and non-metal, so electron affinity, electronegativity, all of them are nearly equal. All of them are nearly equal or nearly equal. Okay, all of them should be equal or nearly equal. Anyway, this is very easy, and all of them are high. All of them must show high ionization potential because non-metals show high ionization potential. The number of electrons in the valence shell should be 4 to 7, except hydrogen atom. Why? Because hydrogen only have one electron in its outermost shell. And the charge, also you should know that beryllium, also I think one other exception should be beryllium. Beryllium does not form any ionic compound. It only forms covalent compound. Though it is a metal, still it forms covalent compound. So you should add it as well. The charge on the nucleus of the atom should be high, and the distance between two nuclei should be very short. This is very true. When the nuclear charge is higher, then the electrons are removed. So the distance would be much shorter. Okay. Anyway, now regarding ionic bond and covalent bond, some other differences are also present regarding properties. This is very easy. Here electron transfer occurs, but here sharing occurs. Here polar, and here the ionic compound is always polar. It can be polar as well as non-polar. The bond is strong, the bond is not that strong. There is no directional property of the bond. This is important. No directional property of the bond. On the other hand, there is directional property of the bond. It becomes ionized, does not become ionized, does not conduct electricity, but it conducts electricity. Some exceptions can be there, but mostly it does not conduct electricity. So this is what we mean by the differences, and it may appear in the exam this way, that which of the following is not a characteristic of ionic compound, which one is not applicable for covalent compound. That's how it will appear in the exam. Anyway, regarding properties, some other features are there. The melting points should be high, while the melting points and boiling points should be low for covalent bond. Crystal granular structure for ionic does not exhibit isomerism. This is a unique property. Isomerism should only be expressed by covalent compound. Okay, the rate of reaction is very slow for covalent compound, while it is fast. Anyway, these are very easy differences. I think you would not face any difficulty to recollect all this. Now, difference between another important two criteria, which is sigma bond and pi bond. We all know that covalent bonding can be explained by molecular orbital theory and orbital overlapping. Since orbital overlapping takes place, it can take place in two ways. head-to-head or side-to-side. Head-to-head overlapping is also known as sigma bond, while side-to-side overlapping is known as pi bond. We know head-to-head overlapping is much stronger than the side-to-side overlapping. So sigma bond will be stronger than pi bond, and pi bond cannot form without any sigma bond. When there is sigma bond, there is an opportunity or window to form pi bond. Without sigma, no pi. So these are written here. We only mark what is important, such as this is face-to-face or head-to-head. This is side-to-side. Now overlapping, as we can see, a sigma bond can be formed with any orbital. Any orbital can form sigma bond, but not all the orbitals cannot form pi bond. Pi bond can only be formed in pure orbitals, except s orbital. Apart from s orbital, since it does not have any lobe, so p, d, f, or rest of the orbitals can form pi bond. Okay, but pi is weaker. Anyway, bond formation, here it is written, it can be formed in both pure and hybrid orbitals. Reactivity, we know sigma bonds are less reactive, while pi bonds are more reactive. As it is weaker, it is more prone to breakdown as well as more prone to react. Expansion specific to a particular region, pi electrons are always in motion. Lastly, geometrical structure. The structure is controlled by sigma bond. Pi bonding does not play a role in the structure of the molecule. And lastly, existence, it can exist at its own without any pi bond, but pi bond cannot exist without any sigma bond. Now, some limitations of covalent bond, as you can see. Limitations regarding covalent bond means in covalent compound, there is a scope of not fulfilling the what? Outermost shell, or completing the outermost shell and beyond. It is labeled as octet contraction and octet expansion. Octet contraction usually occurs in group 13 and beryllium. Usually occurs in group 13 element related compound like boron, aluminium, and also beryllium related compound. And on the other hand, octet expansion occurs in the group. In fact, octet expansion occurs in group 14 to 17, and obviously the period will be third, because from second, third and beyond. Not second. Why not second? Because second does not have any d orbital. Second shell does not have any d orbital. That's why there is no scope of occupying or accommodating those extra electrons that is required to expand the octet. Anyway, these are the MCQ. These are the crucial MCQ that will ensure your chance in better medical colleges. So you should focus on the mnemonic here. In which compound octet contraction occurred? Find out whether it is group 13 or beryllium. On the other hand, where octet expansion occurred? Where in group 14 to 17 elements of third period and beyond. Anyway, now different types of bond in same compound. This is something that we should practice also, because sometimes questions appear this way, that in this compound which bond is present? In this compound which bond is present? How many types of bond are present? And how many bonds are present? These are three different questions. Which bond is present? How many types of bond are there? And how many bonds are there? Regarding a question about how many bonds are there, you have to calculate each and every bond. But without, when the question is asked in this way, that how many types of bonds are there, then you have to find out the different types of bonds and mention the number of types. Suppose in diamine silver chloride, the number of bond is 3 types, which is covalent bond. The type of bonds is 3, which is covalent, coordinate, and ionic. When there is ionic, covalent, and coordinate all together, it mostly act like ionic. The ionic property dominates. But if the question appeared this way, that how many bonds are there? How many bonds are there? In that case, you have to know the structure. As you know, here silver is a plus charged. Silver is a plus. It attracts electrons from 2 ammonia. It attracts electrons from 2 ammonia, and it forms a ionic bond with chloride. So there is ionic bond 1. There is a coordinate bond. How many coordinate bonds are there? 2. Now in the ammonia molecule, there are 3 covalent bonds. So if I write down, there are covalent bond. The total number of covalent bond is 6. Again, coordinate bond, which is also a type of covalent bond. Coordinate bond number is equal to 2, 6, 2. Lastly, ionic. The number of ionic bond here is 1. So altogether the number becomes 9. So 3 different answers for 3 different questions. In this compound, which bond is present? The answer could be any of these 3. In this compound, how many types of bonds are there? 3 types. In this compound, how many bonds are there? 9. So in this way, you will try to understand the bonding in different types of complex ion and complex compounds. Now, regarding delocalization of electron, we know that special type of unsaturation in benzene is observed because of resonance. They do not show color change. They do not show color change in Bayer test. So they do not participate in Bayer test. What is Bayer test? Bayer test means detecting the unsaturation using potassium permanganate. When you apply potassium permanganate in ethene, it will change the color of potassium permanganate and will convert into ethenediol, or which is also known as glyoxal. Okay, that's how it becomes basically it would convert into ethanediol, but ethyne would convert into glyoxal. This is how they get oxidized to form some different compounds, and thus potassium permanganate gets used. That's why the color gets changed. This is what we know as Bayer test. But Bayer test is not applicable for detecting the unsaturation found in the aromatic compounds, because aromatic compounds show a special type of unsaturation because of their resonating electrons. And as we already know, the bond angle, the bond length between carbon-carbon double bond is 0.134 nanometer, while the single bond is 0.154 nanometer. The benzene carbon-carbon double bond shows 0.139 nanometer, which is different from double bond and single bond. So this is due to special type of unsaturation. Anyway, metallic compounds show metallic cluster, malleability and hardness of metals. And lastly, graphite, despite being non-metal, shows electrical conductivity and metallic cluster. This is also a unique feature of graphite. Graphite electrodes are mostly used in our electrolytic cells. Where delocalization of electron occurs. Delocalization of electron is observed in aromatic compounds such as benzene, also crystalline structure of metal. Also, it is observed in 1,3-butadiene. 1,3-butadiene, it would look like this. 1,3-butadiene would look like this. This is not aromatic, but there is delocalized electron. There is delocalized electron, but this is not aromatic. Why? Because it does not abide by the rule of Haeckel's. Haeckel rule should be abide by the, all the aromatic compounds should follow Haeckel rule. What is Haeckel rule? Haeckel rule suggests that every aromatic compound should have 4n plus 2 number of pi electron. And here, n should be equal to either 0, 1, 2, which is whole number. So 2 is a whole number, 2 is a Haeckel number, 2 is a Haeckel number, and 4 is not, right? Here, 2 pairs of pi electrons are there. 2 pair means 4. You should know that if any number which if divided by 2 gets an even number, it will not be a Haeckel number. To detect a Haeckel number, one shortcut trick, please try to remember this lifelong, which is divide it with 2. If you get an odd number, then it's a Haeckel number. If it is not an odd number, it will not be a Haeckel number. As for example 14, if you divide with 2, you will get 7. Odd number, so Haeckel number. But if you divide 16 with 2, you will get 8, which is not odd. That's why it is not Haeckel. Anyway, that's the shortcut trick. And lastly, graphite does show the delocalization of electron, because of which it conducts electricity. Now, regarding the metallic bonds, some metallic bond shows actually metallic bonds are responsible for some important properties. We do not have to read all of the lines from the book. We should only focus on the headlines. Metals show metallic cluster. Metals show metallic cluster. Why? Because of the oscillating electrons, because of the delocalizing electrons. Then it shows thermal conductivity. It is also due to the oscillating electrons. Lastly, malleability and conductivity. Okay, these are very easy. You should only focus on the headlines. And this is also an important. Electron C model is applicable for which bond? Electron C model is applicable for metallic bond. Basically, metal lattice looks like this. All the positive cations or the nucleus is at the core, and it is surrounded by the negative electrons. So it appears like this. Positive ions are immersed or submerged under the sea of electron. This is what we know as electron C model. Okay. Now another property of metallic bond should be hardness of metal. Metals are hard. Okay. And because of the greater the number of valence electron for delocalization, the stronger the metallic bond. This is also important, and this is also crucial for the change in melting and boiling point of metals in D block. It is due to their valence electron. Now, regarding dipole and dipole moment, you should know that what is dipole? Basically, when positive and negative terminal arises within a covalent molecule, then we call it a dipole. And this dipole is a vector quantity. That's why it certainly does have directional property. And if a compound has different dipoles, altogether we have to sum up, we have to calculate the net dipole moment. And if the net dipole moment is 0, then we call it as non-polar. But if there is any net dipole moment, we can call it polar. Now, regarding dipole, we should know only the different charges or poles in a molecule of covalent compound. So what is the property of a covalent? Basically, dipole is a property of polar compound, ionic compound, or covalent compound. We should go for polar covalent as the answer. Types of dipole. Dipole can be 2 types, permanent and temporary. There are some permanent dipole examples. We should memorize this. This is important for medical admission test. What are the permanent dipoles? According to Kovir sir, trichloromethane, propanone, nitrobenzene, hydrochloric acid, hydrogen fluoride, water, ammonia, carbonyl. These are permanent dipole. We have to memorize this one. This is something without any mnemonic we have to memorize. Now, regarding the properties, changes in physical properties of matter, let's read. Formation of hydrogen bond increases the boiling point of substance. Certainly, an additional bond would result into higher boiling point. Because so, let's see, ammonia shows boiling point of minus 33 degrees Celsius, which is higher than other hydrides. Again, the values of melting point, vaporization enthalpy also increased due to the effect of hydrogen bonding. This is very true. So, not only boiling point, melting point and vaporization enthalpy is also dependent on hydrogen bond. Now, from top to bottom in the same group, the melting and boiling point of hydride of the element increase with the increase of molar mass. Generally, from top to bottom in the same group, the melting and boiling point of hydrides of these elements with increase of molar mass. But some exceptions are there. Where the exceptions are there where there is hydrogen bonding. Okay. Now, surface tension and viscosity should also increase due to hydrogen bonding. You may find question like this. What will not increase due to hydrogen bonding? And you may have options like this: surface tension, viscosity of water. In such options will be there, and you have to find out the correct one among them. Now, by hydrogen bonding, the molecules of the substance are joined together to form dimers. So, formation of dimer, trimer, double, or triple structure is possible because of hydrogen bonding. such as ethanoic acid. Ethanoic acid forms dimer. Ethanoic acid forms a dimer because of hydrogen bonding. Okay, the molecular of that's why molecular mass of ethanoic acid seems like 120, though it is actually 60. Okay, carboxylic acids form hydrogen bond in benzene solution, but do not form hydrogen bonds in aqueous solution because of polar attraction. It's obvious. Polar will dissolve into polar substance, polar compounds. Strength of a hydrogen bond. This is very important information. Strength of a hydrogen bond is almost 0.01 times of the bond energy of a carbon-carbon single bond. This is very crucial information. Carbon-carbon covalent bond is 100 times stronger than hydrogen bond. Importance of hydrogen bond is very large. We wouldn't have, we could not survive without hydrogen bonding, because hydrogen bond keeps the hydrates in liquid state. Water is in liquid form because of hydrogen bonding. Anyway, let's see, the role of hydrogen bonding is immense in industry as well. The adhesive action of various gum, glue and dye is also related to hydrogen bonding. Moreover, there are hydrogen bonding in our apparel section, like wool, synthetic carpus, cotton. There is a hydrogen bonding due to which they get smooth. Moreover, our writing paper and ink also contain an immense role of, it also bears importance of hydrogen bond. Wood industry is a large industry, and wood is composed of cellulose, where carbon and hydrogen are there, carbohydrate. So carbon and hydrogen should be there, and oxygen should also be there. Since hydrogen comes with oxygen, it has the opportunity to generate hydrogen bonding. Hydrogen bond gives cellulose its rigidity. With wood, we manufacture versatile furniture and home furnishings. Anyway, now regarding some F block element, we see which one is not the condition of formation of ionic bond. Basically, magnitude of ionization potential of metal is less. No, ionization potential of metal, basically it is true. Ionization potential of a metal should be less. On the other hand, size of metal is comparatively large. Basically, size of metal should not be large. The size of metal should be small, so that it can easily donate the electron. If the size of the metal is small, then the removal of electron would be difficult. If size is large, then the removal of electron would be easier. So it is also true. The question is asking which one is not the condition for formation of ionic bond. We know formation of ionic bond basically dependent on three conditions. One, low ionization energy of metals, high electron affinity of non-metal, and the high lattice enthalpy of the composed lattice or constituted lattice. The size is not matter, but the size is indirectly responsible for the ionization energy. Electron affinity of non-metals have to be less. No, electron affinity of non-metals should be high. This is wrong. This should be high. And lastly, electron affinity of metals have to be less. This is true. Electron affinity of metals have to be less, but this is not the condition here. Okay. Anyway, out of these four options, the better answer would be C, because indirectly this one is correct, indirectly this one is also correct. Only thing that is wrong here is option C. Now, which physical state does not change due to hydrogen bond? Viscosity of water decreases. Viscosity of water decreases. No, viscosity of water increases. Melting point of compound increases. True. Density of ice decreases than water. Density of ice decreases than water. Vaporization heat increases. So basically, which physical state does not change in hydrogen bond? This one, option A. Now, regarding hybridization, let me summarize first. We have to practice a lot regarding hybridization, and we have two options to determine hybridization. How? We can determine hybridization by using a formula, which is number of hybrid orbital will be equal to half into V plus M minus C plus A. Okay, half into V plus M minus C plus A. V, we mean valence electron. So number of electron present in the valence shell of central atom. M corresponds for number of monovalent atoms. Number of monovalent atom. C for charge of cation, while A stands for charge of anion. Here, the charge of cation and charge of anion should be written in the numerical form. No plus minus should be added because of their inherent plus minus. Only the plus minus mentioned here should come to point. The other portion, charge of anion, charge of cation, should come without any sign. Only the digits will be placed. Anyway, this shortcut technique has some drawback. With this, we cannot calculate or determine the hybridization of all the molecules. There are some other technique as well, but let's practice on this later. Where we will get stuck, we will go for the different approach. Now, as you can see, you have to, for practicing medical admission tests, you have to practice at least one from each group. Suppose hydrogen cyanide. In hydrogen cyanide, as you can see, carbon is the central atom. So we have to determine the hybridization of carbon. So to determine the hybridization of carbon, if you look, this is half, valence electron is 4, number of monovalent atom is 1. The number of monovalent atom is 1. Whether it is cation or anion? No. So what it becomes? 5. 5 divided by 2, 2.5. Is it possible to determine the hybridization? No. So this is an exception where this trick will not come handy. So how should we do that? Now let's look at the structure. As you can see, hydrogen cyanide is formed this way. You have to calculate the number of sigma bond at first. You have to calculate number of sigma bond. Here, as you can see, number of sigma bond is 2. Now you have to calculate if there is any number of lone pair electron. Number of lone pair electron. As you can see, there is no lone pair electron, so the answer will be 0. Lastly, you have to find out if there is, I should write it down as an oblique because it is also 0, which is number of coordinate bond. Coordinate bond, if there is any. There is no coordinate bond, which is also 0. So we get to number, if number of hybrid orbital is 2, then the hybridization would be sp. And the structure would be linear, and the bond angle would be 180. Simple. Now, similarly, if we try sulfur trioxide, let's take a page. Let's try sulfur trioxide. As we know, the valence shell of electron half into V plus M minus C plus A is the formula. Here, as you can see, sulfur contains 6 electrons in its valence shell, and there is no monovalent, nothing else is there. So it is 3. The answer would be sp2. The answer will be sp2. Okay. See, we have determined the hybridization of sulfur trioxide as sp2. Okay. Now there is a mistake in your book, which is about chlorate, basically chlorate. Regarding the structure of chlorate, you should know that the structure looks like this. The structure looks like this. So see, we know that there are valence electron. There are 7 valence electron in chlorine. How many valence electrons are there? 7. So if there is 7 valence electron, let's count it. We have 1, 2, 3, 4, 5. And we have only 1 lone pair electron. So if we calculate the hybridization using the structural technique, we can see that number of sigma bond here, as chlorine is the central atom, the number of sigma bond will be 3. Now, if we go for the lone pair electron, as you can see, the number of lone pair electron will be 1. So altogether, the value will be 4. For 4, hybridization should be sp3, right? But in your book, it is by mistake placed in the sp2 section, which is wrong. The answer will be sp3, not sp2. This is a mistake that is placed in your book. Anyway, now let's do that. The same thing with this formula. See, half in chlorine, the valence electron will be 7. There is nothing monovalent apart from chlorine, apart from the central atom, so everything would be 0. But it is not a cation, right? This is an anion. So the charge of the anion would come. The charge of the anion is 1. So again, we get half into 8, which is 4. So similarly, we can come to a conclusion, which is sp3. This is a mistake that is placed in Kobir book. Okay, this is wrong. Chlorate ion shows sp3 hybridization. I'm writing it down here. It shows sp3. Even if you search in internet, you will see that it shows sp3 hybridization. Now, what would show sp2 hybridization? sp2 hybridization would be demonstrated by chlorite, not chlorate. Let me show you. We know chlorite. This is chlorate. Okay. Regarding chlorite, the structure would look like this. 1, 2, 3, 4, 5, 6, and here is 7. So let's see the number of. I have determined the hybridization for this. Okay, this is for chlorite. Now for this is for chlorate, this is for chlorite. For chlorite, as you can see, the number of sigma bond is 2, the number of lone pair electron is 1. So altogether it becomes 3, which is responsible for the sp2 hybridization. So instead of chlorate, the answer here, it should be chlorite, not chlorate. Okay. Anyway, as you can see, there are some different ions here. You should practice. Let me mark some examples which you need to practice for admission test, which may come in admission test. As for example, boron trifluoride, nitric acid, phosgene, phosphate, ammonium, also silicate. Okay, these are some important ions that may appear in your admission test, and you should also try to learn their structure as well as their bond angle. See, for sp3 hybridization, the structure would be trigonal bipyramidal. This is quite easy to remember because 5 is a sum of 3 plus 2. So tri bi together it becomes 5, and the bond angle can be 90 and 120. On the other hand, for 6, the ligand number should be 6. So sp3d2, and it becomes octahedral because of, basically it is a quadrilateral bipyramid. So 4 surface above, 4 surface at the bottom. Together it is octahedral. Lastly, 7 ligands for, not ligands, 7 it is an interhalogen compound. Here as it is 7 fluorines are there, so 7 orbitals, so sp3d3. Again, 7 is a sum of 5 and 2, penta and bi. Okay, it is pentagonal bipyramidal. And the bond angle is 72 and 90. This is also crucial. Regarding the distorted shape of molecule, we know there is a special theory which is valence shell electron pair repulsion theory. valence shell electron pair repulsion theory. According to valence shell electron pair repulsion theory, lone pair repels highest, then lone pair bond pair, and the repulsion between bond pair electron is the lowest. Because of presence of lone pair electron, there are changes in shape. See, as you can see, it is sp2. These atoms show sp2 hybridization. See, chlorate ion is placed under sp3. Chlorate ion is placed under sp3. Okay, if it is chlorite, it should be placed under sp2. Okay, anyway, here as you can see, sp2 sp3 is not important. Important is the number of lone pair electron. Since there is a number of one lone pair electron, the shape becomes v shape instead of the trigonal shape. Similarly, and the bond angle gets reduced from 120 degree. Again, for sp3 hybridization, once the lone pair electron becomes more, from trigonal pyramid to v shape, the shape gets distorted. Examples are very important here. All of them are very, very important. This is a 5-star important. 5-star. Okay, these are very important. You have to memorize all of them. The bond angles are very crucial. In the admission test, you will get puzzled with this bond angle because it is something that if you know, you can answer. Without knowing, you cannot answer that by guessing only. Anyway, similarly, for increase in the number of lone pair electron, the shape gets distorted accordingly. You have to remember the shapes, mostly due to this chlorofluoride, xenon difluoride. The shapes are very crucial, and the bond angles as well. I think this is something, this page demands 5-star, because this is something which is not available in your main book, and you have to read it for better scoring in the admission test. Similarly, for sp3d2, which is applicable for pentagonal bipyramidal structure, but it does not happen if there is any lone pair electron. For single lone pair electron, it becomes a square pyramidal, and for double, it becomes a square planar. Okay, the bond angle stays the same. Similarly, tetramine copper. Regarding tetramine copper, in our Hajari sir book, it is mentioned as sp2d. Okay, this is mentioned as sp2d. sp2d. Okay, this is not dsp2, it should be sp2d. Okay, why sp2d? Because ammonia is a strong ligand and it compels the valence electron of the 3d shell to move further away, and the vacant d shell appears in the 3d. That's why 3d participates in the hybridization, and it results into the square planar shape. It is without any lone pair electron. It does not have any lone pair electron, but the shape gets distorted because of the hybridization, not because of the lone pair electron. Okay, this is something not related to VSEPR. So this is a distortion, but this is not related to valence shell electron pair repulsion theory. This is not related to valence shell electron pair repulsion theory. Now, regarding color of ionic compound, let me mark some compounds which are important for admission test. Not all of them are important. Cadmium sulfide is yellow. You may mark all the yellow altogether, such as cadmium sulfide, lead iodide. See, cadmium sulfide, lead iodide. What are the yellows? Yellow, yellow, yellow. These are the yellow. Silver bromide, and silver iodide. But when it becomes silver iodide, the polarization gets increased. That's why it becomes dark yellow or deep yellow. But silver bromide would be light yellow. Okay, this one is light yellow, this one is deep yellow. So in this way, you can collect all the similar colored compounds together. Also, some other important ones, let me mark it, which are red. Mercuric sulfide, which is also known as cinnabar, I think, is red. Now you have to know about copper sulfide, lead sulfide, and mercuric sulfide, which are black mentioned here. So these are the twists that you have to remember. The whitish one are very easy. Silver chloride is a white precipitate, it is very known to us. So we do not have to waste any time in memorizing this. Lead chloride is also a white precipitate, which is used in identification of different ions. Anyway, this one is important. This cuprous oxide is formed in Fehling reaction, and the color is reddish brown. This precipitation takes place to denote the presence of aldehyde group, free aldehyde group. Anyway, some naming of positive metals or radicals are given in Kovir sir book. This is what it is: hypochlorous, chlorous, chloric, perchloric. This is basically due to the oxidation state. When it is +3, it's chlorous. When it is +5, it's chloric. When it is +1, it's chlorous, hypochlorous. So mark this oxidation state, because this is the responsible number of that name. If it is +1, hypochlorous. If it is +3, chlorous. If it is +5, chloric. If it is +7, perchloric. Okay. Similarly, you should remember what is thiosulfuric acid, what is persulfuric acid, what is pyrosulfuric acid. Very, very important. These are very, very important. Okay, the formula itself is important. H2S2O7, pyrosulfuric acid, also known as oleum. This is also known as oleum. The remaining one, not very crucial, but these three are very, very important. This is also important. What is phosphoric, what is phosphorus, and what is metaphosphoric acid. Okay, and what is phosphorus acid. Based on the oxidation state, the name is given. And this is also a 5-star important chart. Why it is very important? Because questions already appeared from this section. Which one is the formula of blue vitriol? Which one is the formula of green vitriol? Which one is Epsom salt? Not Epsom, it should be Epsom salt. Which is Glubar, not Glubar. This is Glauber salt. Okay. Now zinc sulfide .7H2, it is white vitriol. Sodium carbonate .10H2, it is washing soda or soda ash. That's how you have to remember all the formulas. This is very crucial for admission test. You have to memorize everything. Okay. there is no discount in this section. You have to remember all the formula as well as all the trade names. Geometric structure of chlorate. Since it shows sp3 hybridization, the structure should be what? Though it is sp3 hybridization, but it was placed in sp2 section in Kovicer book. That's why tetrahedral is not an option here. But there is a twist. If you look at the structure, there is a lone pair electron here. Though it is sp3, but there is a lone pair electron. When one lone pair electron appears, then the structure gets distorted. Because as you know, as we have seen already in our that chart, as you can see, chlorate shows trigonal pyramidal structure because of that lone pair electron. Okay. So the answer will be trigonal pyramidal, which basically it is square triangular can be answered. But everything, this is not right actually. Square planar is not right, square triangular is also not right. It should be like this, trigonal pyramid. If it is stated this way, then the answer would be option D. Okay. Anyway, with this, our discussion to our today's class came to an end. Please try to practice the hybridization section as many as you can do, and try to solve the questions that appeared in the question bank in the exercise, because no question will come from the box. Let me assure you that no question will appear from the box. Rather, it will appear from the exercise regarding hybridization. This is my I can confidently say from my experience about that. So try to focus on the exercise questions for the hybridization section. Anyway, best of luck.